I think we're ready to get started. Oh, laten we dan snel even switchen.
Hallo, hallo, hallo. Test, test. Ja.
Oké.
Test? Ja, dus even.
Ja, en dan die dingen om je oren vouwen. All right, welcome everybody. We'd like to take the opportunity to tell you a little bit about improving open source security with reproducible builds. So let's take a quick moment to introduce ourselves. So this is Pjelle van der Waa. He's a participant at RefSpace, and he is mainly interested in reproducible builds from the Arch Linux perspective. And I myself am Arnoud Engelen. I'm active at Hack42, and I'm coming from the JVM angle. So this talk will be a general talk, so not specifically for Arch or the JVM, but just I think making the case that reproducible builds is a useful concept to improve the security of open source software. So this will be a dual presentation. I will take care of the first part, and then Jelle will take over for the second part. So this is the quick overview of the agenda. So first, let's make the case of why we think this is needed at all. Then explain what reproducible is and looks like. And then go into more detail of how you do it, what tools are available to you to improve your security with reproducible builds, and some current developments and future work in this area. So let's start with why this is important in the first place. So let's do a sort of like lightweight risk analysis. Why do we have to care about this? So are attacks on open source software relevant in the first place? Well, spoiler alert, we of course think so. So Black Duck Open Source did a survey. Unfortunately, they stopped in 2016, but they have some nice numbers where most numbers they surveyed, and of course this is a little biased, but would say they run on open source software. And as reasons for that, they cite things like the quality of the solutions, features, technical capabilities, and the possibility to customize and fix. So it's no longer from a cost perspective, but more these kinds of reasons to choose for open source software. So well over half of companies would consider FLOSS options before looking at proprietary alternatives. A report from a little more back is from the US Department of Defense. And so these guys saw, hey, within our organization, there's an increasing amount of use of free and open source software. Maybe we should look into that. Maybe we should write a report about, is this a good idea? Should we ban this? What should we do with this? So the interesting results from this report was they actually depend heavily on free software. The overwhelming recommendation was not to ban free software at the Department of Defense, and actually invest in it, promote it internally, and make use of it more effectively. So I think we've come a long way. Like when I started in open source 20 years ago or something, it was like pretty exciting if you saw like actual commercial products who were running Linux or using open source. It's completely the other way around now. Like all the big financial institutions, big corporations, they rely heavily on open source. So I think it's worth it to make sure that the pipeline from development of open source software to the actual running of it in production is also secure and no malware is inserted in that process. Okay, so does this actually happen? So are developers targeted to impact actually their users and their customers? Because that is what reproducible target builds help secure, is the gap between the developer on one side and the person actually running the code on the other side. Well, yes, this actually happens. So there was this one guy who took some time to look into Homebrew. So Homebrew is a package manager for macOS. It's very widely used. And this guy just like looked at the Jenkins configuration and found some keys. So basically, he could have owned the Jenkins machines of Homebrew and basically to take control over the macOS machines of everyone who used Homebrew. Luckily for us, in this case, he didn't, and he did a responsible disclosure. But this is pretty scary. Now, of course, this went well, because this was a white hat guy. But even more recently, in November of last year, there was a very widely used Node.js package, which fell into the wrong hands, and there was some malicious JavaScript code added to their deployable. It was fairly hard to detect. I mean, they made some mistakes making it easier to detect in this case. But this actually went live, and actually this code made it into a lot of places. So luckily for us, this malware was very targeted. So they specifically targeted one downstream application in which they injected some kind of Bitcoin wallet stealing thing. But this is really scary, because a lot of our like critical infrastructure, large organizations are relying on these kinds of libraries. And if they get malware injected into their systems, of course there's like more ways to contain that risk, but it's very scary. So luckily, there's a lot of things we can do to make this less scary and less prone to attacks. One thing to make clear is that I'm talking a lot about the risks of open source software. On the other side, there's proprietary software. The risks are even bigger there, because there you actually have no way at all to verify that there's no malware in the binaries. In open source software, at least you have some chance. And we will show here that there are some tools to make more, to leverage that those capabilities more. Okay, so let's look at the open source development pipeline in a little bit more detail to see where reproducible builds fits. So I think in like a bird's eye view, the development process looks like the developer writes some code, commits it to source control, then builds and packages it, the package is distributed, and then the user runs the software. Now let's take a quick look at what can go wrong and what we can do against it. So if the developer writes code, what can go wrong? Well, the developer himself can be malicious. That's a problem. But also a non-malicious developer can be blackmailed, can be coerced, maybe by the government, maybe by some criminal organization or individual. And also, he can go to a hacker conference or some other place where he doesn't take good care of his machines, and his machine can get compromised. So there's a very real chance that the developer gets infected. So what can we do about this? I don't think we can do a lot. But I think we can take some countermeasures so it doesn't matter that we don't fully trust the developer in this side. Because the developers commit to source control. So here's, you can, the threat can be that the source control hosting is compromised, But luckily, we can use signed commits. In some cases, it's easier to see if something deeper in the commit tree was changed. I'm not going to go too deep into this, but the point is, at some point, you can do an audit of the source code, both manually and automatically, and you can ensure yourself that there's nothing weird in there. The next step is building and packaging. Here we can have problems because our dependencies are already attacked, or when our build machine is attacked. Well, when our dependencies are attacked, basically we're out of luck. So what we have to do there is we have to also verify the integrity of the dependencies we use. For the compromised build machine, that's where reproducible builds comes in. So that's the area of the pipeline that reproducible builds helps secure. Well, then the package is distributed. That's not really a solved problem, I think, but at least it's a well-known problem. So yeah, basically signatures, checking, those kinds of things. Can't do a lot more.
Wouldn't reproducible builds also help with this? I mean,
Yeah, it's a little blurred, but yes. Yeah. So recapping, developers write code committed to source control. It's built and packaged. The package is distributed. The user runs the software. Well, we can't really secure the developers, but we can check that there's no foul play in the source control tree. Then we can build and package it, and we hope reproducible builds will help here. Distribute that package, and then check that the reproducible builds certified package is indeed distributed to all participants. Okay, so now I hope I have convinced you that reproducible builds, that the open source development pipeline is something that's worth protecting, and that there's a hole in the build system step of the process. And that hole is, what if the machine where you're building your artifact, what if that machine is compromised somehow? Then you're out of luck, and then you're distributing malware to your customers and to your users, and that would be bad. So if we assume source control is okay, then the concept of reproducible builds is that we don't build and package our software once, but we build it multiple times on different and really different machines. So a diverse set of machines. And then we check that the diverse set of machines, they all come to the same resulting artifact. So this means if one of the machines...
So if one of the machines is compromised, then you should see that it's not consistent.
Exactly. So that doesn't solve compromised machines, but at least you can detect it if one of your machines is compromised. Of course, if all your machines are compromised, you're still out of luck. But I think this is a useful thing to check. So typically, this would be a CI machine and maybe some other environment like a developer machine. If those agree on the packaged result, then you have a much higher confidence that there's no foul play injected there. But for this to happen, so this sounds pretty simple and obvious, right? But for this to happen, we need to remove unreproducibility from the build and package step. And that's the practical work that we need to do to achieve the goal of reproducible builds. And Jelle will go into some sources of unreproducibility in a little bit. But reproducible builds, besides I think the main advantage of checking that none of your build machines are compromised, has some other advantages. So in one case, the distribution, the build process of an application generated the key at build time. And some distributions generated that key at the build server and then distributed it to all the clients. So this was obviously not what was intended, because now everyone was sharing the same key instead of every user having the same key. And using reproducible builds uncovered this problem in the packaging of this application. So here it was more of a bug in the packaging than in the building of the software itself. But this is also part of the build cycle. It can also help in caching. So for example, the Bazel build tool, when it builds a large project, then it builds a dependency tree of all the parts of the project. And if we now, so here we have a main which depends on main.cc and an intermediate result which depends on x.cc. If we now change x.cc, but we only change a comment and we run the build tool again, then it can see that the result x is the same as last time, and it doesn't have to compile main again, because nothing changed, nothing material changed. So these kind of caches work much better if your build is reproducible. So reproducible here really means bit per bit the same result, and because you get bit per bit the same result, these kinds of caches get much more efficient. And if you set up things right, you can even use a distributed cache in your organization, which has its own problems, but it can make things a lot faster. You want to pick it from me?
Okay, sure. So other bugs, other advantages are bugs found when building in different environments. For example, if you have sorting with different locales gives different outputs, or shell-specific bugs. A bug we had in our Pacman package manager is that it calculates the size of a package, but the calculation method differs per file system, which introduced non-deterministic packages and uncovered an actual software bug. There are also builds which were found which failed X% of the time, like race conditions, or when you run stuff, when the developer only runs it on one thread and you run it on 4. Yeah, weird things can happen. And now we're going to talk about how, in practice, so this reproducible builds concept was started, let me see, I believe 5 years or 6 years ago. And, well, how hard can it be to compile software on 2 different machines and get the same result? Well, that's actually pretty hard. So the first time Debian attempted this, they got 24 packages reproducible, and a lot of problems were found, which led to more tooling to be made. So this is where I will talk about now. So the most common unreproducible builds are caused, for example, by iterating over hashes, which is usually not deterministic. So you have to sort them first. Most compilers record the build path in your binary when you create a debug build. This is obviously unreproducible because my build path is probably not the same as yours. A big issue was timestamps, which were generated on build time, which led to non-deterministic builds. Herefore, actually, a specification, the source.epoch started, which, if in a special environment a variable is set, it will replace the timestamp set in the C header, for example, which makes the build deterministic. File ordering, so for example, if you have some assets which you need to build into your binary and you do a redir of this directory, then the file ordering isn't the same on all file systems. Private keys or seeds were already mentioned. And a lot of binaries or configuration files, they rely on specific user groups, which you might not have. Oh yeah. So here, for example, timestamps. This is still an issue in a lot of packages. So that file ordering. A private key which is generated on build, and another fun one was an initialization seed, which would be the same for every package, which is obviously bad. To help detect these issues, we have the Reproducible Builds project created a set of tools. And the first one is diffoscope, which is a diff on steroids. And it's more than your average diff tool because it can handle multiple formats. So, for example, here's an example of the batch firmware, which runs your batch. If you compile it twice, it outputs a different. It records a timestamp in its firmware, which is unreproducible, which can be easily found with a diffoscope because it supports a lot of files and has some nice codes to unpack, for example, an APK file into binaries, and then it will diff them. There's also a tool created if you want to build your software twice, which is a really convenient tool, and you just pass it your build. So, for example, reptest make, and then you have to specify the output binary, and it will run them in two different environments with different variations, which you can specify. So, build path, timestamp, time zone, and it will output if it's reproducible or not. When the Reproducible Builds project started, there was a need for a test framework, and there has been, and now a lot of distributions started joining in. So Debian started it with it, and now also Arch, OpenSUSE, and even Coreboot, OpenWRT, and F-Droid have started getting included into this test framework. What it basically does is it runs builds twice on different machines with different variations. And the variations are the build user, the GID, UID, build path, the kernel, the CPU type, and in the end it will compare hashes and determine if the build is reproducible or not. So you can see here that the green is what is currently reproducible. This is for unstable. So that is different for stable, because unstable has more variations in their reproducibility. And so this environment is currently set up. There are patches being sent upstream now for several years. And I believe there was, if you can see here, it was like 80%, Debian was 80% reproducible. What they're still working on some tool change fixes, because they want to remove the build path from being recorded when creating debug binaries for GC, for example. Currently, also the Debian policy is to have you should make your package reproducible. It's not a requirement yet, so this is something they will consider in the future. They're also not comparing yet the actual packages, which they put in the repositories. This test setup really just builds it twice, and it doesn't try to rebuild a package which is currently in the repository. For example, also the Debian image is not reproducible yet because of squashfs not being able to recreate reproducible images. And another interesting thing is this whole reproducible concept wouldn't work without a nice way to integrate it in your distribution. So there needs to be some way for the package manager to check if a package is reproducible. And this is something which is being discussed and now. Actually, last year there was a Reproducible Builds Summit in Paris, where there was talk about how can we inform users that their package, which they download from, for example, the Debian repository, hasn't been tampered on the build server. So that basically the idea is the distro builds a package. We have a set of trusted rebuilders, which if a new package is uploaded, rebuilds the package. They have some sort of API where they publish their results. This is integrated in your package manager. If you try to install a package and it's not reproducible, you get red flags. So, for example, this could be how it would look like. This isn't set in stone, but apart from so the initial effort with reproducible build started with making Debian reproducible, and then a lot of other projects joined in. And there are also people trying to make GDKs and Java environment reproducible. For example, you could argue that you want PyPy packages to be reproducible. F-Droid is working on getting reproducible APKs. And there's a new project in Toto, it's been around that, which is more about also securing your supply chain by adding metadata to every build step you have, and with that metadata you can verify that the build hasn't been tampered with. And another initiative which started was Reproducible Builds. This aims to, it's arguably even more insane, it aims to reduce the amount of binaries you need to bootstrap, for example, a GCC compiler. Because currently, if you want to build your GCC compiler, you already need a GCC compiler, but can you trust that your current GCC compiler hasn't been tampered with? This is not part of the reproducible builds project, but it is another interesting issue we have in the open source world. So I guess that kind of concludes it. If you want to get involved, the Reproducible Builds website has talks, has a lot of documentation. If you are a developer and you want to check if your package is reproducible, it has also all talks and slides where you can learn more. The Reproducible Twitter account where you can follow status updates every week. There's a blog update with the current progress in various projects on reproducible builds. There's on OffTC is an RC channel where you can join if you want to help out, have questions, or you can ask us. So, thank you. Are there any questions?
Yeah, I have one question.
Yep. Hot.
So I had one question, which is not entirely related to reproducible builds, but more to the whole risk analysis at the beginning. When you set a full place because of a bad committer or whatever to detect it, that you couldn't detect it at the individual committer level, but you could detect it at basically the version control system, the SCM level. What we see though is that there are a lot of projects, and especially in something like the Node.js space NPM, where everyone doesn't want to reinvent the wheel, so they rather bring in a module for 5 lines of code than write 5 lines code themselves, is that you get single maintainer projects. What about, for example, LeftPod, of course, was an example of this. And in a way, the whole Bitcoin heist thingy at NPM also was Well, there was only one maintainer who gave up, and then someone else took over. So again, single maintainer. So what does that do to the risk analysis if you look specifically at single maintainer projects? And then
Yes, good question. This is a little bit outside of scope of reproducible builds specifically, but it's definitely an important subject. So I think there's a number of things we can do. I think better change tracking and better automated, I hesitate to use the word audit, but all kind of code checking tools which check that there are no strange changes and no changes that appear to rewrite history. On a little bit bigger scale, we need to get better at transferring ownership and sharing ownership of these kinds of projects, which is a huge open question, I think. I mean, there's a lot of interesting initiatives in this space. There's projects to fund these kinds of things, like Open Collective. There's a number of others whose names escape me right now. We'll have to see how well that will work. So yes, this is an interesting space, definitely.
okay, thank you.
Yes?
I don't get how the end user verification works, because you were explaining that my distribution builder is doing the reproducible build part. So they have a build farm which contains of multiple different types of servers. They all produce the same binary. Distribution maintainer signs it and then gives me the package, and I go, okay, I trust my distribution provider. I don't see how tooling on my end would be able to verify the reproducible build without actually building it myself.
Well, the thought is that it should be easy to set up for a third party, so not related to your distribution, to be able to
Third party is me, because I don't trust anyone else.
yeah. So yeah,
Because if I have to trust someone else, then it's basically at the same security domain as my distribution provider, which means, and that's exactly the guy I'm not trusting right now.
mhm.
So it has to be me, or I have to be able to find an external service, but we're being paranoid because it's a security domain. So it has to be me.
Yeah, so for our Linux, we definitely want it to make it easy for a user to reproduce packages. But yeah, that wouldn't be integrated into the package manager, because the package manager part is more thought of that you have a sort of verified trust third party which is independent of your distribution, which rebuilds the packages.
But it's just another external entity I have to trust, and I already
True.
trust my distribution builder to not give me crap. So we're assuming that my distribution builder is giving me crap, so I have to go around that, and then going to another third party it doesn't fully cover the risk I have there. But if you look at the implication, then if I have to build my own packages anyway, why do I need a distribution builder? Why can't I just take the source code and have a third-party build farm that says, okay, we did like 1,600 of these, and then I build my own and I compare? But I don't really see the use case, how verification works, and how you don't end up in a scenario where it's not, well, yeah, the Dutch proverb is slager die zijn eigen vlees keurt. The butcher that checks his own meat. Because
Well,
it kind of feels like that. I think
I have something to say about it, but I think your neighbor also has. So
Yes,
Go
so
for
let's say you're using Debian and you're not sure, you don't trust Debian, or maybe you trust, the thing is not about not trusting Debian, it's
Yeah.
about trusting Debian but being afraid that someone manages to get a backdoor access to the Debian build infra and inject bad code into binaries that way. So you take a second, a third party, not you, a third party, which you also trust, which could be, say, the Dutch government or whatever. Let's say the Dutch government hooks into this and they do their own rebuild servers. So they rebuild all the packages, because you don't want every user building their own packages, because, well, then installing LibreOffice takes 2 days. So let's say you trust the Dutch government and they offer a service with a public certificate and everything, so you can verify you're connecting to it. And then your package manager can tell you need to also check the package hash with that Dutch government server. So that's the whole concept, that then an attacker would need to both infiltrate Debian and the Dutch government build server to be able to get bad binaries.
And in the same way, they would have to infiltrate them in precisely the same way.
Also, yes. Well, they would need to inject exactly the same code.
But that way you want more. You don't want just
Yes, you
the
definitely
government-
want not only multiple rebuilders within, for example, the Debian organization, but also as many third-party rebuilders as you can find. But those don't need to have to be the same machines as the machines you will want to install things on. That's a different concern. So if you trust no one, then the only thing you can do is just audit the source code yourself, all of it, and build it. Good luck. Right now, like the status quo without reproducible builds, is you actually trust the machine that specifically built this binary. That's pretty bad. So reproducible builds is somewhere in the middle. And of course, for end user verification, there's a web of trust kind of problem. So if there's someone you know who knows someone who you trust that is part of the rebuilder pool, then something like that will have to raise your trust at least.
And then making the web bigger increases the trust you have in the result of the reproducible build system.
Exactly, yes. So that's for end user verification. Of course, there's also the other angle is for Debian, or in my case, for the supplier of an open source Java library. It is in my interest that I do not want to ship backdoors to my users and customers. So I myself will use diverse machines on my own machine, Travis CI, hopefully some people from the community to rebuild, to check for foul play, and to increase our own trust that our binaries are not vulnerable. Yes.
Cool.
Thanks. Anyone else? All right.
That's it. Yeah.
That's it. Thank you very much.
Thank you, Bart.